this is the MCQ series for all electronics exam preparation. In today's video, we are going to see the questions from transistor session. So we'll be discussing the MCQ questions. So transistors are one of the very important topics when you go for any competitive examination of electronics. So we are going to see some questions in this video. Along with each question, I will try to cover up maximum theory associated with it. Okay. So the first question is, you can see the question now on the board. A transistor has dash. So this question is asking about the number of PN junctions present in the transistor. And the options are 1 PN junction, 2 PN junction, 3 PN junction, 4 PN junction. So let us have a look on how the symbol of a transistor is looking like. So if you draw a transistor symbol roughly like this, so there is mainly 3 terminals. There is an emitter, there is a base, and then there is a collector. And we represent like this. There is E, there is B and C. So this is the 3 terminals: emitter, base and collector. These are the 3 terminals, and in between these 3 terminals you can see there is 2 lines, right? And these 2 lines are representing 2 junctions. So how many PN junctions are present? There is 2 PN junctions. There are basically 2 types of transistors based on the materials that we use for making it. That is for making it. There is, I'll write here itself, there is NPN type of transistor, and also there is PNP type of transistor. Now this NP, these are actually representing the type of semiconductor material. There are 2 types of extrinsic semiconductor materials. There is N type and then there is P type, right? So there is 2 type of extrinsic semiconductor materials, N type and P type. And by combining these 2, we get the NPN and PNP type of transistors. So here if you see, there is one P material, there is another N material. And here there forms a junction which is again a PN junction. Here also the same case. There is an N, there is a P, and here again we will get a PN junction, right? So same with the case of NPN transistor also. Okay. So there is 2 type of transistors. There is NPN, and then there is another type which is called the PNP. Okay. In both this case, there are how many PN junctions? There is 1, 2 for this case, and also 1, 2 for this case. Okay. So totally there is 2 PN junction, and the correct answer for the first question is nothing but option 2, which is 2 PN junctions. The question is, in a transistor IC equal to 100 milliampere, IE equal to 100.2 milliampere, the value of beta is dash. Okay, so before that I want to tell you the basics of common emitter configuration. Okay, so there are 3 types of transistor configurations. I have talked about this in detail in another video, and the link of that video I'll be sharing in description. Okay, towards the end of that video you can find a detailed description about the 3 configurations, the current gains, voltage gains, everything. Okay, so please do check out the video. I'll be putting that in description. Okay, anyway, let us have a look on the common emitter configuration. So there are 3 type of configuration. There is common emitter, common base, and then common collector. These are the 3 configurations. Now we are going to see about the common emitter configuration. So just like its name is indicating, the emitter is common. We are going to apply the input to the base terminal of the transistor, and the output we are going to take from the collector terminal. Okay, so these are the 3 terminals. Emitter, will keep it as common. Base is taken as an input. We will apply the input to the base terminal. Output is taken from the collector terminal. Okay, so in this configuration, that is in the common emitter configuration, the current gain we denote using the letter beta. Okay, current gain means how much gain there is happening for the current. So we apply an input current, we get an we apply an input current and we'll get an output current, right? And how much amplification or how much gain is happening to this current, and it is represented using the term which is called current gain. Okay, so current gain is nothing but it is equal to output current, that is IC, by input current IB. Okay, so output terminal is collector, so IC. Input terminal is base, so IB. Right, very simple. So this is beta and the letter, that is letter of representation is beta and the expression is IC by IB. Here in this question, what all things are being given? You have the value of IC that is equal to 100 milliampere, right? And then they have given the value of IE, that is emitter current, which is 100.2 milliampere. So these two things are given to us, but we need IB to find the value of beta clearly from the expression, right? Now, how can we find the value of IB? There is again an expression for finding the value of IB by using the relations between these three currents. Okay, I'll write that relation here. The emitter current IE is given by the sum of two currents from the collector and from the base. Okay, so if you go into the theory of transistors, you will get to know how the current is flowing. The current is actually starting from the emitter side and then to the base and then it reaches the collector. Okay, so the total emitter current is actually getting splitted across these two terminals, base and collector. That is actually happening here. Okay, let's not go too deep into that. Let us stick to this expression, that is the total emitter current is equal to collector current plus base current. Okay, now from this expression we can actually find the value of base current, right? Because we know the value of emitter and collector current, right? So we'll substitute it here. 100.2, all the values are given in milliamperes. Okay, so 100.2 is equal to, you will get it as 100 plus IB, right? So from this we will get IB is equal to 100.2 minus 100. That is 0.2 milliampere is the value of your base current. It has to be very low. Base is actually a very thin layer. Okay, so the base current will be also very less. Okay, so we will get the value of IB as 0.2 milliampere. Now substitute that here in this expression and then find the value of beta. Because you have the value of IC, now you have the value of IB also. Directly you can substitute and find the value, right? I'm going to just remove this. I'm going to write the expressions here. So IC is equal to 100 milliamps by 0.2 milliamps. Upon dividing this, you will get the value as 500 and the correct answer is option 4. Okay, so the correct answer for the second question is option 4. Next, let us move to the third question. Okay, let me remove this. Okay, so the third question we are going to discuss is again a small numerical question. So here the question is, in a transistor, if beta equal to 100, generally the value of beta for common emitter configuration, we take it as 100 or it will be given in the question. Okay, in a transistor, if beta is equal to 100, collector current is 10 milliampere, then emitter current is dash. Again we have to go with the same equations to find this. Okay, I'll write down the values first. Beta is given as 100 and we know beta is equal to IC by IB. I'll write that also. We have been given the value of IC as 10 milliampere. We have to find the value of IE. Okay. Now, from this expression, if you substitute IC here, because beta is also given, we can find IB. And again by the expression for IE, which is equal to IC plus IB, we can find the value of total emitter current also, right? So that is how you have to proceed this question. First, I am going to find what is the value of IB. So from this expression, that is from this expression I can write IB is equal to IC by beta, right? IC is 10 milliampere by beta is 100. Okay. Relationships between current gains. Okay. So the question is like this. The relation between beta and alpha is dash. Okay, so we have discussed about beta, and beta is common emitter current gain. Okay, I'll write down the three configurations and their current gains and the there is the relations between them. Okay, so there is common emitter, there is common base, and there is common collector. These are the three configurations. Here in the common emitter, the current gain is beta, and here for the common base, the current gain is alpha, and here it is gamma. So I'll strongly recommend you to watch the video I'll be putting in description. Okay, so please check out, I have given in detail. Okay, so here for the common emitter configuration, the current gain is beta, for common base it is alpha, and for common collector it is gamma. Okay, so these are the three current gains. And the expressions also I'll write. For beta, the equation is IC by IB. We have already used this equation. And for alpha, the equation is IC by IE is the equation. Okay. So here for the common base case, current gain is alpha, and the expression is like this: IC by IE. Okay, output is taken from collector, input is given to emitter. And for the common collector case, the expression or the equation is like this: IE by IB. Okay, so this is the three expressions for the current gains. I'll also try to draw the case, that is where the input is given, where the output is taken. So this is common emitter, right? So emitter is common, input is given to base, output is taken from collector, right? And here the base is common, input is given to emitter, output is taken from collector, right? So by using this, you can actually find, there is actually recognize how this expression is coming. Okay. Here collector is common, input is given to base, output is taken from the emitter side. So just know that current gain is nothing but output current to input current. See, output current is emitter or IE, input current is IB. Okay, just like this here also. Okay, now the expressions is beta, alpha and gamma. Now what is the relation between these three? Let's write. Beta is equal to, this is very, very important. Okay, beta is equal to alpha by 1 minus alpha. Okay, so this is the expression for beta and its relation with alpha. And alpha is equal to beta by 1 plus beta. Okay, just note down this expressions. And gamma is equal to 1 plus beta. So these are the three relations. And these relations are very useful while solving the problems. Okay. Now in this question, they are asking the relation between beta and alpha. And beta equal to alpha by 1 minus alpha is the expression. And the correct answer coming is option 3. Anyway, just note down these three expressions: beta, alpha and gamma. Okay, and also the equations: beta equal to IC by IB, alpha equal to IC by IE, and gamma equal to IE by IB. Okay. So the correct answer for the question is option 3. Okay. The next set of questions are theory questions only. So the next question is, the number of depletion layers in a transistor is dash. Okay, so we have actually talked about the number of PN junctions. The same number of depletion layers will be also formed. So when there is a PN junction, there will be a depletion layer also. Okay, so we'll draw a rough figure. Okay, so there is emitter, and then there is a small base, and there is a collector. Okay, so this is how a transistor is generally looking like. And we have discussed that there are two PN junctions, one here and one here. So when there is a PN junction here, after some time it will get depleted, and there will be depletion layer also. Okay, so number of PN junctions is equal to number of depletion layers formed, right? So correct answer is option 4. There is 2 depletion layers will be there in a transistor. Okay, the next question is again from the config or the structure of a transistor itself. The element that has a biggest size in a transistor is dash. Okay, options is 1 collector, 2 base, 3 emitter, 4 collector base junction. Okay. So if you properly draw a transistor structure or a symbol, it will be like this. There is one terminal which is called emitter and its size is moderate. Okay. And then there is a small base. Base is the smallest. And the collector side or the collector terminal is the biggest in size, or it is the largest sized. Okay. So there is emitter, base and collector. Out of this, clearly from the picture itself, we can understand that the collector is of the biggest size. Okay. So the correct answer is option 1, which is collector. Okay. So the next question, that is this question, correct answer is option 1. Okay. Next, again from the structure of a or a configuration of the transistor, the question is coming. Okay. So next question is, in a PNP transistor, the current carriers are dash. Okay. I'll draw here PNP itself. So there is P, there is N, and there is P. So in the PNP transistor, you can see the number of P sides are more. So P sides means P-type semiconductor. In a P-type semiconductor, the majority are holes. Okay, I'll write that here. There are two types of semiconductors. There is P-type and then there is N-type. In the P-type, there is more holes and in the N-type, there is more electrons. So when there is more holes in the P-type, here we can see P terminals are more. So holes will be more. So the current carriers will be holes. Okay. So correct answer is 4. Holes are the current carriers. But actually the thing is there is hole and these holes are actually vacancy of electrons. Okay. Now, let us not go that much deep. Okay. You will get confused. Okay. Just know that for P-type semiconductors, the holes are majority. That is, they are the majority, and we are using more P elements here. So holes will be more, and they are the current carriers. Okay. Correct answer is 4. Holes is the holes are the current carriers. Next question. It's again about the doping. Okay. So the question is from the doping of a transistor. The collector of a transistor is dash doped. Okay. I'll write here emitter, then I'll write base here, and then I'll write collector. Okay. So there are 3 terminals and the doping level of these 3 terminals also vary. Okay. There is emitter, there is base, and there is collector. This emitter is heavily doped. Now we are going to see about the doping level. Okay. Emitter is heavily doped. So if you have at least the basic idea about semiconductors, doping, etc., you should know that the emitter is heavily doped. The base is lightly doped. Okay. And the collector, it is moderately doped. Okay. Moderately doped, right? So this is how the doping level varies. The heavily doped is the emitter. Base is lightly doped. It is actually acting as a junction between the emitter and the base. Okay. So this base is very lightly doped and collector is moderately doped. The question is asking about the collector of a transistor is dash doped. It is moderately doped. Just draw this figure somewhere. It will be very useful for you. Okay. Correct answer is 2, that is moderately doped is the answer. Okay. Next question. Again a theory question. A lot of these type of theory questions can come in your exams. Okay. Next question. You can see on the board. A transistor is a dash operated device. Okay. A transistor is a dash operated device. Options are 1 current, 2 voltage, 3 both voltage and current, 4 none of the above. Okay. So there is BJT and then there is FET. Okay. So BJTs are bipolar junction transistors and they are current operated. Okay. Then there is FETs, which is called field effect transistor. Field means voltage. So this is voltage. Field effect. So the effect of voltage is actually happening inside the field effect transistor or FETs. Okay. So this is field affected or this is voltage operated. Okay. So these are the two types of transistors. Okay. There is BJT and then there is FET. The BJTs are current operated devices. FETs are voltage operated devices. Here the question is about transistors or simply BJTs. They are current operated and the correct answer is option 1, which is current. Alright. Okay. So just write it, that is write this thing also somewhere. It is useful. Okay. The last question for this video is this. In a NPN transistor, dash are the minority carriers. Okay. Now we are going to discuss about the NPN transistors, right? So this is N, then there is a small p, which is a base, and there is again an N, that is the collector. Okay. Write that here, emitter, base, and collector. Okay. 3 terminals. And here we are taking NPN configuration. So NPN N. Okay. So the question is, in a NPN transistor, minority carriers are dash. Okay. So here there is 2N. So when there is more N means more number of electrons. Okay. So the majority carriers are electrons. So I'll write majority here. So when electrons are majority, which will be minority? Holes is minority. Minority. All right. So this is how it is coming. So when there is more N means more electrons. When more electrons means lesser number of holes. So the minority carriers are holes. So the correct answer is option 2. Okay. So the last question is this. So in this video, we have actually discussed on the basics of transistor structure, its configurations, terminals and all. Also, we have managed to do 2 questions. That is 2 numerical questions also. So we'll be continuing this series and we'll try to cover all the important subjects and topics of electronics. We'll do these type of MCQ questions. Okay. So I'm really hoping that you found the video useful. If yes, please like the video and share the video with your friends. And if you want to see more of these type of contents, please do subscribe to the channel. Thanks for watching and keep on watching.